What if I told you that the war in Ukraine has been quietly threatening the future of your smartphone and the chips inside your computer? Not through missiles or sanctions you read about in the headlines, but through something almost invisible. A gas. A single, purified gas that most people have never heard of, pumped through machines in clean rooms thousands of miles away. For years, a surprising share of the world's supply came from a few unremarkable facilities, and many of them sat inside Ukraine. The gas is neon. To most of us, it means glowing signs in a city window, the soft red light of an old bar. But the neon that matters to the technology industry is something far rarer and far purer. It feeds the lasers that print the smallest features on a microchip, and without a steady stream of it, some of the most advanced manufacturing on Earth can grind to a halt. That is the strange truth hiding behind your devices. To understand why, you have to look inside a machine called a lithography scanner. Making a chip means drawing circuit patterns far thinner than a human hair onto a wafer of silicon, and to draw lines that small you need light with a very short, very precise wavelength. One workhorse technology uses what is called a deep ultraviolet laser. Inside that laser sits a mixture of gases, and the dominant ingredient by volume is neon. It acts as a buffer, shaping and steadying the energetic pulse of light that does the actual etching. Now here is the catch that makes neon a chokepoint. The laser does not sip the gas gently. A single advanced scanner can consume enormous quantities of neon over its lifetime, and the purity requirements are brutal. The gas must be cleaned to a level measured in parts per billion of contamination, because a trace of the wrong impurity can throw off the laser pulse and ruin a wafer worth a small fortune. So the industry needs not just neon, but a relentless supply of neon refined to near perfection. Where does neon come from? It is not mined or drilled. It exists in the air around us, but only as a vanishingly small fraction, roughly 18 parts per million. To collect it, you separate air into its components by cooling it until it turns liquid, then capturing the trace gases that boil off. That process demands gigantic air separation units, the kind that already exist at one particular type of facility: steel mills. This is where the story turns toward Ukraine and toward the Soviet Union before it. Steelmaking needs vast amounts of oxygen, so the old Soviet planners built enormous air separation units beside their steel plants. Engineers realized those units were also pulling neon out of the air as a byproduct, and rather than waste it, they built the capability to capture and purify it. The expertise and the hardware became concentrated in a region that, after the Soviet collapse, ended up largely inside Ukraine and southern Russia. By the 2010s, this had hardened into a genuine dependency. Industry estimates suggested that something on the order of half of the world's semiconductor-grade neon was being purified at facilities in Ukraine, with key operations clustered in cities like Odessa and Mariupol. A handful of companies, refining a gas captured from steel plants, were quietly feeding the lasers of chip fabs in Taiwan, South Korea, the United States, and beyond. Almost no one outside the industry knew the link existed. The fragility of that arrangement had already shown itself once. Back in 2014, when conflict first erupted in eastern Ukraine and Crimea, neon prices spiked dramatically, climbing several 100%. Chip makers got a warning. Some of the larger ones quietly began stockpiling and looking for backup sources, treating the gas like a strategic reserve. But the warning faded, prices eased, and for many in the industry, the cheapest path was simply to keep buying from the same Ukrainian suppliers. Then came February of 2022. Russia's full-scale invasion swept across Ukraine, and the neon plants sat directly in the path of the fighting. In Mariupol, the city was besieged and devastated, and its production halted entirely. In Odessa, operations were suspended as the country shifted to a war footing. In a matter of weeks, a large share of the planet's semiconductor-grade neon supply simply stopped flowing. The fear was immediate. Analysts warned that a global chip industry already strained by pandemic shortages could be pushed into a fresh crisis. Neon prices surged again, in some reports rising many times over within months. Headlines speculated about smartphone and car production seizing up for want of an invisible gas. The chokepoint everyone had ignored was suddenly the most discussed bottleneck in technology. And yet the catastrophe many predicted did not fully arrive. The reason is that the lessons of 2014 had not been entirely forgotten. Major chip makers had built up neon inventories, in some cases enough to cover months of production. Just as importantly, the high prices and the obvious risk lit a fire under alternative supply. Producers in China, the United States, South Korea, and across Europe moved to expand their own neon purification, capturing the gas from their own air separation plants. That scramble reshaped the map. Within a couple of years, China in particular had ramped up neon output sharply, and the world's reliance on Ukrainian supply fell from dominant to merely significant. Some Ukrainian producers also adapted, moving operations or restarting where they safely could. The single point of failure was being deliberately spread out, because every buyer had now seen, in vivid detail, what happens when one fragile link snaps. But the deeper lesson is not really about neon at all. Neon is just one of dozens of hidden inputs that modern chipmaking quietly depends on. There are rare gases like krypton and xenon, ultrapure chemicals, specialty metals, and exotic equipment that only a few companies on Earth can make. Each is a thread, and the semiconductor supply chain is woven from thousands of them, often without anyone holding a complete map of where every thread comes from. The neon chokepoint is a warning written small. A gas captured almost by accident beside Soviet steel furnaces became, decades later, something the most advanced industry in the world could not easily live without, and almost no one noticed until war forced the question. The devices in our pockets feel clean and self-contained, but trace them backward far enough and you arrive at a steel mill, a cryogenic tower, a war zone, and a handful of facilities holding up far more than their size would suggest. The next time a chip shortage makes the news, it is worth asking which invisible thread is being pulled and how few hands it runs through.
If you found this deep dive valuable, hit the like button, drop a comment below on what tech mystery we should decode next, and subscribe to never miss an episode.